Okay, in this video we want to talk about some more with factoring, and specifically what are you supposed to do when the number in front of x squared does not equal 1, like you see right there. So remember in the last video we talked about standard form, which is what I'm writing right here, ax squared plus bx plus c. And in all the other examples that we did, the a number, which means the number in front of x squared, was always equal to 1. What are we supposed to do when a does not equal 1? Because here's the problem. If we factor this right now, in the past we were always putting two x's here. X times x does not equal 6x squared. So we're going to have a problem. So there's two ways there's actually more than two ways. There's a lot of ways you can do this. I'm going to show you what I think is the easiest way. Okay, one way that some people will show you is they'll encourage you to guess and check. So what that means is you could, for example, say, how can I multiply to 6x squared? Well, I could do 6x times 1x, or I could do 3x times 2x. And then how can I multiply to 10? I could do 1 times 10 or 2 times 5. Okay, the problem with guess and check is you'll be able to see on this example there's a lot of different combinations. So how do I know that the 1 goes here and the 10 goes here, or maybe it's opposite? Maybe 10 goes there and 1 goes there, or maybe 2 goes here and 5 goes here, or maybe 1 goes here and 10 goes here, and I'm supposed to use 6 and 1 instead of 3 and 2. Okay, so you can see that would get overwhelming pretty quick. It's usually not a good idea to guess and check. Certainly not for this example. So I'm going to show you, like I said, there's many different methods you could use for this. I'm going to show you what I think is the easiest way, because I think it's probably not good to know 5 or 6 methods and get overwhelmed with many different ways. It's better to just have one clear way to do it and to stick with that and get good at that. So that's what I want to show you. Okay, so there's a simple 4-step procedure, and the name for this method is called the swing method. Okay, it's called the swing method because the first step is we need to, and I'll try to use different colors here to keep it organized. So we use green for the first step. The first step is to swing a, and by a I mean a is the number in front of x squared. So in this case a equals 6. The first step is to take the a and to swing it over to c, and c of course means this last number. What do I mean by swing it over? It basically means to multiply. So if we swing that over, it becomes x squared plus 19x, and then the 6 gets multiplied by 10. Okay, so that's the same as multiplying a times c. So step 1 is swing a over to c. Step 2 is this one, it's factor, and we've already done problems like this before. We did this in the last example. We're looking for numbers that multiply to 60 and add to 19, and those numbers turn out to be 15 times 4. Okay, you could make a table for that like we did before. Numbers that multiply to 60 add to 19. 1 times 60, that doesn't work, that adds to 61. 2 times 30, that adds to 32, that doesn't work. 3 times 20 doesn't work because that adds to 23. But 4 times 15 does work because that adds to 19. Okay, so that's step 2. So we swung it over, we factored. Okay, now here's the problem though. If at this point, if we were to check this using FOIL, x times x does not equal 6x squared. So the question I have for you to think about is, where did the 6 go? And the answer is the 6 went into this 60. That's how it became 60. We took the 6 and we swung it over here. So the 6 is in the 60. That means it's still in the 15 and it's still in the 4. And if we want to get it out, which we do, because we need to make it equal this original problem, okay, how do we get it into the 60? We got it there by multiplying, so the way that we get it out is we divide it. Okay, that 6 got swung into the 60 by multiplying, so we will get it out, or we'll reverse that process by doing the reverse of multiplying, which is dividing. Okay, so this is step 3. Divide by a, what we just did, and now simplify. By simplify, I mean if you look at those fractions, they can be simplified. 4 over 6 simplifies to 2 over 3. 15 over 6 simplifies to 5 over 2. You only simplify if you can. In this case, we could. Obviously, if that were 5 over 6 instead of 4 over 6, you can't simplify that. Okay, so we're done with step 3. We divided by a, we simplified. Last step is step 4. We need to swing it back. Okay, so whoops, I didn't number this step, but this is step 3. Okay, step 4 is we swing it back. So again, if we do x times x right now, we're still not getting 6x squared. So what we need to do is take this 2 and swing it in front of that, so it becomes 2x plus 5. And then we need to take this 3 and swing it in front of that, and that becomes 3x plus 2. Let's check it now. If we FOIL it, 2x times 3x, that does equal 6x squared. And you could check the rest as well, but it will work. So this right here is our final answer. 2x plus 5 times 3x plus 2, and that is called using the swing method. So what I want you to do is try to pause the video right now and see if you can work through the following two examples using the swing method. And when you're ready, hit play. We'll take a look. Alright, so let's go through these. So the swing method, we always start by taking the a value. And again, a is referring to, when we put something in standard form, a is the number in front of x squared, or in this case p squared, the variable doesn't matter. So in this case a is 4. We take that and we swing it over. So we'll have p squared, it's supposed to be a minus right there, minus 21p, and then 4 times 20 gives us 80. So we're looking for numbers that multiply to positive 80, add to negative 21. The numbers that multiply to a positive and add to negative would be two negatives. And it might be hard to tell off the top of our head what those numbers are, so let's make our table here. So we're going to need two negative numbers. And let's start with negative 1 times negative 80. That adds to negative 81. Negative 2 times negative 40 adds to negative 42. 3 doesn't go into 80, 4 does. It's 4 times 20, and when we add those we get negative 24. Next ones would be negative 5 times negative 16, and those are the ones that add to negative 21. So we'll put those numbers here. Okay, next step, and this is the step that a lot of people forget about, they forget to check that p times p does not equal 4p squared, so we don't want to stop right there. We have to ask ourselves, where did the 4 go? And it got swung into this 80, which means it's still in the 16 and the 5. And we swung it there by multiplying, so we will get it back by dividing. Okay, next thing we have to do is simplify this. So 16 over 4 just becomes 4. So that simplifies to that. This one cannot be simplified any further, so we need to swing it in front. So it becomes 4p minus 5. And now if we were to check this, 4p times p, it does equal 4p squared. And obviously you could FOIL the rest, but that will end up working. So our final answer is going to be 4p minus 5 times p minus 4. That's our result. Alright, last one right here. Let's swing 6 over to 28 as our first step, because this would be terrible to do by guess and check. 6v squared could be v times 6v, or 2v times 3v, and then 28 can be 1 times 28, 2 times 14, 4 times 7, and then we have to try every one of these combinations with each of these, and then of course we have a negative 28, so we have to deal with the positive and negative. That would be too much to do by trial and error, so it's better to have a method. That's why we're using this method here. So we'll swing the 6 over 6 times negative 28 is negative 168. Okay, we're looking for numbers that multiply to a negative, and the only numbers that do that are one positive and one negative. Multiply to negative 168 and add to positive 17. Okay, so let's try to find those numbers. One positive, one negative. We could have 1 times negative 168 or negative 1 times positive 168. That's not going to work because those add to different versions of 167. Okay, we could have negative 2 times 84 or positive 2 times negative 84. That's not going to work either. Okay, we could do 3 times 56 or negative 56 or negative 3 times positive 56. You can see obviously we're getting closer to what we want. That's not going to work. Negative 4 times 42 will be 38. Obviously the other version would be negative 38. That's not going to work. 5 doesn't go into 168, I should say. 6 does, though. It turns out to be 6 times 28, or 6 times negative 28, or negative 6 times positive 28. Once again, that doesn't work. The next number that works would be 7. 7 goes into that negative 24 times, or negative 7 goes, sorry, I'm running out of space here. Let me add it right here instead. Negative 7 times positive 24, or positive 7 times negative 24. This is negative 17, but we want it to be positive 17, and so it's this one. So v minus 7, v plus 24. We're almost there. We can't forget this important step. V times v does not equal 6v squared. Where did the 6 go? It got swung into here, which means it's still located in those numbers. We swung it there by multiplying, so we'll get it back by dividing. So 24 over 6 simplifies to just 4. This can't be simplified, so we'll swing it in front, and we get 6v minus 7. And there's our final answer. V times 6v equals 6v squared, and you could FOIL the rest, and it will end up working. So that's called the swing method. It definitely takes a little bit of practice if you've never seen it before, but it's very useful, and it's definitely an improvement on trying to guess and check all those different options. So hopefully that makes sense.